For this problem, we're going to use Pythagorean theorem. This is on the TAN homework assignment. So we are given A and B's length. We are trying to find C. We know this is a right triangle, so we know that the Pythagorean theorem will work for this triangle. It only works for right triangles, right? And that we know this statement will be true. We are given A and B. We can substitute those values into this equation and use it to solve for the unknown variable. So it says A is 6, so I just substitute that in place of my A. We know that B is 11, and we are trying to find C, which in this case will be the hypotenuse, which it always will have to be the hypotenuse for the C in the Pythagorean theorem. You must make sure you put them in the correct order. Okay, equals C squared, 6 squared, 36, 11 squared, 121, equals C squared. 36 plus 121 is 157, equals C squared. And then, how do I get C alone? Again, that's our goal, to solve for C. Well, there's an inverse of squaring, just like there's an inverse of multiplication or addition. Inverse of multiplication is division, inverse of addition, subtraction. Inverse of squaring is taking the square root. So I square root both sides. The square and the square root cancel. That's what it means to be inverse functions. They undo each other. So C is actually equivalent to the square root of 157. We could try to simplify that radical. If we know if there's any factors of 157, we can see if any numbers go into that. In this case, I don't believe there will be any, so we'll just use the calculator to find the square root of 157. So square root 157 is about 12.53. 12.53. Square root of 157. On your calculators, the gold ones, it'll be, there's a second button and then a x squared button down on the left, and you'll hit second x squared, and there's a little radical sign there. So this will be approximately 12.53, and don't forget the units. Well, here they don't give units, so we could just say units to indicate this is length we're talking about. Notice I put the approximate sign. This is length, it's not area, so you wouldn't want to do units squared, you would want to just do units. So it's approximately 12.53 units. Just to check again, just like we did with the trig problem, is this a rational answer? Does it seem reasonable? Well, we're trying to find the longest side. The shorter sides were 6 and 11, and this one is longer, so if we'd got something smaller than 11 or 6, we would have been concerned, but it seems to be a reasonable answer, so we can move on.